Hey guys, it's Miss Johnson and I'm here to bring you our very first video of the Intermediate Algebra curriculum. We are on Unit 1, Notes 1. Today our learning target is I can solve multi-step equations. So this is your very first video that you're watching for this class. A couple of things to think about. You might want to have you definitely want to have your notes sheet out in front of you. So find your note sheet that says Unit 1, Notes 1 up at the top. You're also going to want something to write with because we're going to be writing a lot of stuff down. You also might want to have your calculator because we'll be doing some calculations throughout the notes. So take a minute and find those things. Also, keep in mind that this is a video that goes at your pace. So at any time, if you need to pause, rewind, rewatch, take a break and come back, you're free to do that. So this is under your pace and your control, and you make this work for you. So here's our learning target for today. I can solve multi-step equations. Up at the top, we're going to talk about the 4 steps to solving those equations. So the first thing that we want to look for when we solve equations is if there's anything on either side of the equal sign that needs to be simplified. So simplify each side of the equal sign separately by distributing and combining like terms. So look for any distribution that is there and any like terms that need to be taken care of. The second step is to gather the variables to one side of the equal sign. So I'm going to make sure that if I see x on both sides, that I'm going to subtract one or add one over to the other side, depending on how I would cancel that. So I want to make sure my variables are on the same side, on one side of the equal sign. The third step is to use addition or subtraction to cancel the constant. If you don't remember that word constant, a constant is a number without a variable. No variable. And we use addition or subtraction to cancel those. If there's a number that's just by itself, I need to cancel that, move it to the other side of the equal sign. And then the last step is to use multiplication or division to cancel the coefficient. And the coefficient, this word, is the number with the variable. Okay. Now again, if those steps went too fast for you, feel free to rewind and listen to them again, or to pause the video for a second so that you can finish writing what you need to write down. We're going to move on to number 1. So in number 1, I have the equation x plus 5x minus 5 is equal to 1. So the first thing that I want to do is look for any distribution. And when I look for distribution, I'm looking for sets of parentheses. Now in this case, I don't see any sets of parentheses, so I can skip that part. But I do see some like terms. So if I think of my equal sign that's right here as kind of the separation of the left and the right, over here on the left-hand side, I see that I have an x and a 5x. Now, x and 5x are like terms. And if you don't remember, the coefficient that's in front of x by itself is a 1. So if I put those like terms together, 1 plus 5 gives me 6. So I have 6x. I haven't done anything with the minus 5, and I haven't done anything with the 1 on the right-hand side. So now I would go to the next step, which would be gather the variables to the same side. Well, that's already taken care of for me. I have an x over here on the left, no x's on the right, so I don't need to move anything. I'm already done with that. So the next thing I would do is cancel the constant. Now the constant, think of our goal. Our whole goal is to get this x by itself. Okay, if you want to write that down, our goal is to get the variable alone. Sometimes we would also call that isolate the variable. So you might hear those words too. So if I look at the side that has the variable, I have a coefficient of 6 and I have a constant of -5. So the next thing I need to do is get rid of this constant. We're kind of like unwrapping a present here. So we first, put these together, then we're going to work from kind of our outside in to get to that x. So I'm going to add the 5. And we all know that we have to keep equations balanced. So whatever I do on the left-hand side, I'm going to also do on the right-hand side. So then that cancels that because -5 plus 5 is 0. And we all know when we add 0, nothing changes. So then I have 6x is equal to 1 plus 5, which is 6. Then the last thing that I need to do is get rid of this coefficient. Now 6 and x are being multiplied, so I need to use division to cancel it. I always want to do the opposite operation. Like up here where I had subtraction, I added. Here I have multiplication, I'm going to divide. So again, whatever you do on the left, you have to do on the right. So I get rid of those 6's and I have x alone. Yay, that's my goal. Now I need to simplify over here, and 6 divided by 6 is 1. So that is the answer to that equation. Let's try number 2. In number 2, I have 6x minus 11 is equal to negative 6x plus 5. So again, your equal sign is kind of the breaking point, the separation between the left-hand side and the right-hand side of the equation. If it helps you, you can go ahead and draw a line down from that equal sign so that you recognize what's on the left and what's on the right. So in our first step, I need to look for like terms and any distribution. Over here, I don't see any distribution and I don't see any like terms. This term has an x and this one doesn't, so I can't put them together. On the right-hand side, again, no parentheses, so I have nothing to distribute, and no like terms. That's an x, that's a constant, so I can't put those together. So I'm done with step 1. I couldn't do anything with step 1. But in step 2, where it says gather the variables to the right, to the same side, I can do something with that. I have an x over here on the left and an x over here on the right, and I can't solve it that way. I have to put those x's together. So you have two choices. You either subtract 6x or add 2x. Now, I like to work with positive numbers, so I always move the smaller one. So I'm going to add 2x to both sides. Negative 2 is smaller than 6, so I'm moving the negative 2. That's going to make that whole term drop out. Negative 2x plus 2x is 0, so that whole term went away. And then I combine these two. 6x plus 2x is 8x. I still have the minus 11. I still have this 5. It's still equal in the middle. Then I need to get rid of the constant. So the constant, remember you're trying to get this x alone, so work on the side that has the x. The constant is negative 11, so I'm going to add 11 to both sides. That cancels that. I'm left with 8x is equal to 5 plus 11, which is 16. Then the last thing I need to do is divide by that 8, because that's a coefficient, and I have x is equal to 2. So there's my solution. Let's take a look at 3. In 3, now I have some distribution I have to take care of. Anytime we have this set of parentheses with a coefficient out front, that coefficient goes to both parts inside. That's what we call distributing. And this is being multiplied. Okay, so negative 4 times x is negative 4x. And negative 4 times negative 3 is positive 12. I haven't touched that negative x that's on the right, so I'm just going to rewrite it. Now I have variables on both sides. I have an negative 4x over here on the left, and I have a negative x over here on the right. So what I'm going to do is move the smaller one. Negative 4 is less than negative 1, so I'm going to add 4x to both sides. That whole term will drop out on the left. But we have to keep our equations balanced, so I have to do the same thing to both sides. So now I have negative 1 plus 4, which is positive 3. Over here on the left, I got rid of that x term, which was my goal. That's what I was trying to do. And now I'm left with just 12. Then the last thing I can do is divide by 3. And I have 4 is equal to x. 12 divided by 3 is 4. Now, on a multiple choice test, or when you're working with inequalities, you're going to usually want to write the x on the left-hand side. So that would be x is equal to 4. This isn't a wrong answer by any means. It means the same thing. And equal signs can be flipped because they're the same in both directions. So it doesn't matter, but typically you'll see it with the variable written on the left. All right, one more in this section. I have negative 10 is equal to 1/2 x plus x. So I am going to take a look for any distribution or like terms. I don't see any sets of parentheses, so there's no distribution to take care of. But on the right-hand side of my equal sign, I have some like terms. I have 1/2 x plus 1x, and I need to put those together. So my negative 10 I haven't done anything with. Then I'm going to add 1/2 plus 1. That's 1 1/2 x. Now, if it's easier for you to look at this as a decimal, that's totally fine. 1/2 is the same thing as 0.5, so I'd have negative 10 is equal to 1.5 times x. Then the only other thing I need to do, there's no constant to get rid of, because if I look over here with the 1/2 x where I'm trying to solve, this is my goal. So there's no constant that's being added or subtracted out here, so there's nothing that I need to move over to the other side. I go straight to the one with dividing by the coefficient. So I'm going to divide by 1.5. Divide by 1.5. So now this is where you're definitely going to want to use your calculator to help you out a little bit. When I take negative 10 and divide by 1.5 in my calculator, you're going to get something that looks like this, negative 6.666, and so on. There's a couple of ways to write that. You can write that as negative 6.6 repeating is equal to x, or recognize that 0.6 repeating is the same thing as 2/3. So negative 6 and 2/3 is equal to x. Both of those are completely correct answers, and you can write it either way. Okay, so now let's talk about proportions. So when I have a proportion, that's when I have two ratios that are equal to each other. Remember that ratio is just kind of a different way of saying a fraction. Okay, so two fractions that are equal to each other, two ratios that are equal to each other. That's what a proportion is. So it's going to look like something like this. I have, let's say A over B is equal to C over D. Now, whatever those variables are equal to, that's what my proportion looks like. I have a ratio on the left, ratio on the right, equal sign in the middle. Now, when we solve proportions, we want to cross multiply. We're going to multiply the top on one side times the bottom on the other, and it's literally going to cross the equal sign. So I would multiply A times D and set it equal to B times C. Then set the cross products equal to each other, like I just said, and solve the resulting equation. Okay, so we're going to cross multiply and solve the equation that we're left with. That's how we kind of take care of those fractions, get them out of that fraction form so that it's a little bit easier to work with. So let's take a look at number 5. In number 5, I have 15 over 2 is equal to x over 8. So that's my ratio that's set equal to each other. I'm going to cross multiply those. So I have 15 times 8 is equal to 2 times x. Now, this is an equation that I know how to work with. I'm out of the fraction form, and I can solve it just like I know. I need to simplify this part. 15 times 8 gives me 120. 2 times x is just 2x. I would look for my steps. I'd look for any distribution. There isn't any. I would look for variables on both sides. I only have one variable. I'd look for a constant. I don't have one over here. So the only thing I need to do here is divide by the 2. And 120 divided by 2 is 60. So I have 60 equals x, or in other words, x equals 60. In number 6, I have 6 over x is equal to 3.27 over 11. Now, there's a decimal up here, but the process is still the same. I'm going to multiply top on one side times bottom on the other. So I have 6 times 11 is equal to 3.27 times x. 6 times 11 is 66. 3.27 times x is just exactly that, 3.27x. Again, no like terms, no distribution, no constant even to get rid of, so I'm just going to divide by the 3.27. 66 divided by 3.27, when I type that into my calculator, I get 20.18, I think it was 3 something, and it went on and on and on, was equal to x. If I round that to the third decimal place, I'm sorry, if I round that to the second decimal place, I need to look at the 3 to tell me what to do with the 8, and 3 tells me to keep the 8 the same. So I'm going to say that it's 20.18. Anytime you round, you're no longer equal, you're now approximately equal. So I use those little squiggly lines, that's the approximately equal to sign. X is approximately equal to 20.18. Okay, so that's solving that one. Then in number 7, now cross multiplying, I got x in a couple of places. This could be interesting. So when I cross multiply, I have x times 3, and I have 2 times this whole thing, x minus 2. Now do yourself a favor and put it in parentheses, because what happens here is you're going to have some distribution that you have to take care of. So I have x times 3, but I also have 2 times this whole quantity. This quantity is a group, so I need to make sure I put parentheses around it and distribute that 2. That's going to be 3x is equal to 2x minus 4. Okay, so make sure you put parentheses around that and use distribution. Now I can solve the rest of this. I have x's on both sides, so I need to take care of that. I'm going to subtract 2x, because again, I like to move the smaller one. It just keeps my x's positive. It wouldn't matter if you went the other way and just filled in a 0 and then added your 4. You would have gotten the same answer. But anyway, 3x minus 2x gives me 1x left over. These went away. Don't forget about this negative sign that's in front of the 4. That's affecting the 4, so I need to keep it. So I have x is equal to negative 4, and that is my answer. All right, so let's flip it over to the back. We have a word problem to take a look at the top. It says your school is building a new computer lab. 400 square feet of the lab will be available for computer stations. Each station requires 20 square feet. Write and solve an equation to find out how many computer stations can be placed in the new lab. Okay, so the first thing we have to do whenever we have a word problem like this, we have to figure out what we're finding. What is the question? Write and solve an equation to find out how many computer stations can be placed in the new lab. So that's what's going to get our variable, because that's our unknown. That's the thing we're trying to find. So the x is going to be the number of stations, computer stations. Okay, then we got to ask ourselves, what's happening to that variable? Well, that variable, the number of computer stations, each station requires 20 square feet. So I'm going to have 20 square feet times every station in the lab. And I know that I have a total of 400 feet available. So this is going to equal the 400 feet. Okay, then I need to solve this one, and this is a pretty simple equation. All I have is one step. I need to divide by that constant. So I would divide by 20 on both sides, keep my equation balanced, that goes away. 400 divided by 20 is 20. Now, every single question that has words needs an answer with words. Okay, that's a mantra that you'll hear me say a whole lot this trimester. Every question with words needs an answer with words. So what am I finding? This is 20 stations. So 20 computer stations. Okay, and that would be my answer. All right, so now let's go into some words that translate into certain expressions so that we can help solve these word problems a little easier. In this table, we're going to fill in all of these operations that translate into these words, or that these words translate into, and then we're going to just see a little example. So the first one, added to, increased by, more than, some, addition to, that all means add. And then if I looked at the expression 5 increased by a number, that's 5 plus some number we could call x. The second one, subtracted from, decreased by, less than, difference, taken away. All of those words translate into subtraction. Then if I look at the example, 4 less than a number. We need to be careful with one like this because a lot of people want to say that that's 4 minus the number, but 4 less than the number means that you're actually starting with x and subtracting 4. You're taking 4 away. So the minus 4 has to come after the x. The next one, multiplied by, product, times, a third of, half of, twice. All of those things mean multiplication. And then if I look at the example, it says 5 times the sum of a number and 9, or I'm sorry, the sum of 9 and a number. So 5 times, that tells me that I'm multiplying. Sum tells me that I'm adding, and I'm adding 9 and a number, so I need to put those things together in a group. Take 5 times that. So this looks like 5 times 9 plus x, some number that I don't know. Quotient, divided by, split into, groups, pieces, all of those things mean division. Twice the sum of a number and 8 divided by 3. Twice the sum of a number and 8. So twice tells me I'm taking 2 times something. Sum of a number and 8 means I'm putting those together, divided by 3. So I have twice the sum of a number and 8, that's x plus 8, all divided by, the whole thing is divided by 3. That's what that expression looks like. When I look at Squared, I know that I'm taking some number to the second power. So 4, there's that less than again. 4 less than the square of a number looks like x squared minus 4. When I look at cubed, I know I'm taking some number to the third power, and you can write that in there too. This would be the same as to the third power. Okay, to the third power. This squared one is to the second power. Now, a lot of people look at expressions like this and want to call it x2 or x3. It's not x2, that's x times 2. It's x to the second power, or x to the power of 2, or x squared. All of those ways of saying that are right. If you tell me x2, I'm definitely going to correct you. So just be careful how you say that out loud. So now twice a number decreased by, that decreased is subtraction. Twice means 2 times the cube of the same number. So 2x minus the cube of the same number, which is x to the third power. That's what I'm looking at there. To the nth power looks like this, x to the n. Okay, we don't have an example phrase over there, but that's okay. And then the last one is, same as, is equal to. All of those words mean equals. So the length of a rectangle is, tells you equals, twice the width. That's L equals 2W. That's what all those expressions translate into. So let's go through some examples in 9 through 13, just some easy ones. The sum of a number and 16 is 32. That looks like x plus 16 equals 32. In 10, the product of 16 and a number is equal to 32. That looks like product is multiply, so 16 times x equals 32. The quotient tells me divide. Quotient of a number and 16 is 32, so I'd have quotient of a number and 16. That means the number goes on top, the 16 goes on the bottom, is equal to 32, and that just goes in order. Quotient of a number and 16. Number divided by 16. The fourth power of a number is 16. That means I have x raised to the fourth power equals 16. And the difference of a number and 16 is 32. Difference of a number and 16 means I have x minus 16 equals 32. Last question for our notes for today. It's in number 14. It says a rock climbing gym charges non-members $16 per day to use the gym and $8 per day for equipment rental. Members pay a yearly fee of $450 for unlimited climbing and $6 per day for equipment rental. Write and solve an equation to find out how many times you must use the gym to justify becoming a member. So again, I want to start with what am I finding? What is my variable? So write and solve an equation to find out how many times you must use the gym to justify becoming a member. So x is going to be the number of times at the gym. Okay, and usually you notice in the last word problem that we did and in this one, you find it towards the end of the whole paragraph, usually in the last sentence. Okay, now I'm going to go back up to the top and I'm going to reread it. Okay, it says a rock climbing gym charges non-members $16 per day and $8 per day for equipment rental. Members pay a $450 fee plus $6 per day. So all these per days are our x variable. Okay. So I have two things going on here. I have something for the non-members and I have something for the members. Okay, and I want to know when are those two things going to be equal. So let's just look at the non-members. Non-members pay $16 per day for the gym. Then that's just a walk in the door. Then they also pay $8 per day for the equipment. Those were both per day things, so those both got the x variable. Then members pay $450. That's a flat rate. $450, that's like a fee, okay, for unlimited climbing. And, meaning add to it, $6 per day. So plus 6 times every day they walk in the door. Here's our equation. Now we need to solve it. Okay, so over here on the left, I see that I have like terms that can be put together. 16 plus 8 gives me 24. So I have 24x is equal to 450 plus 6x. I also notice that I have x's on both sides that I need to subtract. So I'm going to subtract this 6x over to the other side so that my x terms are then together. That gets rid of that. 24 minus 6 is 18. So I have 18x is equal to 450. Then I also need to divide by the 18, and that will give me my answer. I end up with x is equal to 25. So what that means is I need to go to the gym 25 times or 25 days. 25 days at the gym to justify becoming a member. Sorry, that was a bad box. That's okay. Um, I need to go to the gym 25 days to justify becoming a member. So then you can ask yourself, when will that happen? If I go about 2 times a month, that gets you to the 25 days. Okay, so then you can say, well, am I going to go 2 times a month? Maybe, maybe not. And you decide, should I just stay a non-member or become a member? Okay, that takes us to the end of our first video. So don't forget to check off your note sheet with Ms. Johnson and pick up your practice sheet, and you can work on your assignment from there. Thanks for listening and have a great day.